Da. Okay. First one, number 29 here. Number 29 talked about, it had viewing windows. And this is something that we talked about in class, but you might have forgotten because I didn't review it yesterday with you, but I was hoping that you'd kind of remember, but I had a couple questions yesterday about it in the afternoon, so I thought I'd better cover it right now. So on number 29, 20, I think it started 29, 29, 30, 31, 32 or something like that, where they gave you graphs down below, like they had A, B, C, and D for graphs, and in the graphs, it was a very like generic graph. They just had a couple markers, something like this. And the thing was, up above, on number 29, it had something like this. It had -5, 5, 1, by -5, 5, and 1. Okay, that was breadth. Okay, what you're looking at here is the viewing window. You're trying to pick out which graph, and again, I think there was 4 or 5 graphs down below, A, B, C, D, E, or something like that, where you're trying to figure out which graph goes with this viewing window. So, whatever graph it was, let's say this is letter C, I have no idea. Let's say that's the C graph. Does it match these in standard? These are your x-axis numbers, these are your y-axis numbers. So you're going from -5 up to +5 along the x-axis, and they're jumping by 1s. Or you're starting on the y-axis, starting at -5, going up to 5, going by 1s. And maybe that's exactly what you have here. So that's the viewing window. Does that make sense, like what it's going by? You're trying to pick out which window represents the numbers that are in that thing. So if it happened to be something like this, -10 up to 10, and it's jumping by 2s, and that was the same for both, -10 up to 10, jumping by 2s. This could be the same window, because if I'm jumping to -10 up to +10, -10, -8, -6, -4, -2, 0, 2, 4, 6, 8, 10, that could have been the same thing because it jumped by 2s. Does that make sense, like how they could do it? By whatever it jumps by and how many markers they have. You're trying to figure out which letter goes with which problem. So your answer for number 29 in your, in your homework, number 29, all you're going to write down is like C, like which graph goes with it. Does that make sense? Like that's all you're writing? Trying to figure out which graph goes with that problem. Any questions on 29 through, what is that, 32 or something like that? Okay, that's, I just had a bunch of questions on it yesterday. I thought I covered it last week, but I guess I didn't review it yesterday, so it kind of threw some people for a loop. Let's jump to the next page, 159. I want to look at number 77. Now remember, on number 4 and 5 on page 159, I had different instructions. I want you to give me all the relations for those coordinates. Even if it was a yes/no question, you do have to give me all the relations. But I want to talk about number 77. 77 on 159. 159. There it is. Okay. -1, -4, 1, -3. 1, -3, 1, -4, and it's something like this. Correct? That was your number 77. Now yours look a little wider because I think they spread it out a little bit more. But there's your graph. And the questions, if you look at number 77, it had like 4 or 5 different questions. It said, name the intercepts, name the domain, name the range, name the values below the graph that are stated. So if I had to name the domain, maybe that was one of the questions. Domain is all the x numbers. Is there any breaks in this graph at all? No. So and the kind of the arrows are going outwards. So the domain is going from -infinity up to +infinity. I'm using every x, geez, I should use parentheses here. I can use every x number from -infinity up to +infinity. There's no breaks in the graph. If it wanted range of this graph, now we have a problem. Because what's my lowest range number on number 77?
-4.
-4 was that was the lowest number, and it was a closed circle, and then it went up from there. Because again, you're using the y numbers. So the lowest point is -4, and we're going to +infinity. Remember, you always have to go least to greatest. Notice that I used a bracket at -4, you include it. Infinity you don't include because it's just a direction, it's not a number. That's range. I think that was one of the questions. Second one, maybe it asked for intercepts, x-intercepts. So one of the x-intercepts was -1, 0. One of the other x-intercepts was -3, 0. Or actually it was positive 1, 0, sorry. That's your x-intercepts. Maybe it wanted a y-intercept. I don't even know where that thing hit on the y-axis. Was it 2, 3? It hit 3, -3. So the y-intercept was 0, -3. That was your y-intercept on your graph. Sorry, my picture's really bad. And then the one question I want to answer is that last one. Because it's kind of what you did on all the problems leading up to 77 and number 81. It was the 65 through whatever. Below this graph, they had a couple questions where it said, what happens at these two numbers? And they had a little question mark and had another one with a question mark, right? Those are at the bottom of each graph in 77 and 81. This one I want to make sure that you understand what it's asking for. I think this is like part E or something like that on number 77. It said find the values that for the following find the missing function values indicated by these question marks. And it was -2 to 2. That's what the question was asking for. -2 to 2, right? Well, what this is, and it's kind of like we did in 65 up through 76, find -2 on the x-axis is your x number, and it wants to know what is the y number that matched with it. So at -2 on the x-axis, what was the number that it went through? That's what it's looking for. Well, if you look at your graph, -2 over negative, it looks like it's -2 and it's dropping down to -3. Sorry, my picture's really bad. But it was supposed to hit down here. So at -2, it's hitting -3. That's where the graph was supposed to pass through. So you'd put a -3 here. This is what you'd write for that last one. That's what I want to see. At -2, you're hitting -3 on the y-axis. That's where the graph passed through. On the other side, 2. Here's 2. Now you have to figure out where up here it went. Because again, you're going 2 on the x-axis, you have to figure out the y number that currently matches with on the graph. Does that make sense, like what you're looking for? The y value at 2? And I think that's 3 if I'm not mistaken. No, it's way higher than that. It's 5? Way up there. It's way up here. It's 1, 2, 3, 4, 5. It hit up here. Boom. So it's hitting 5. So you put 5 here. You have to look at where that arrow is going, what direction it's going towards. Questions at all about this function? Like how you're supposed to do number 77 and 81? Okay, I want to clarify that because I don't know if I talked about those last ones. Some people are going to wonder what it was asking for. These are at the bottom of the graph, and they're asking what the values are that are coming out of that thing. Okay, at some point today, I do want to give you time to actually work on that, so I'm going to try to go through what we're going to be going into in the next section. We're going to do like a light introduction into section 1.2, 1.3. Okay, we're good though? Okay, perfect. So you put your homework away for right now. We'll come back to it here in a second. I just thought that was kind of interesting. We needed to talk about that. It's kind of one of those things like you just need to see it to kind of get a hold of it. So. All right. This section that we're going into, 1.3, it has some basic stuff that you've definitely seen before, where you have domain, range, we have new terms now, we have like maximum, minimum, that's something we're going to introduce. Relative max and mins, that's something, but we're going to introduce something that we're going to use in calc, and this is the start of what I consider the challenging material, where it's just this section is the third section we're in, because the second section was kind of what we just did in the homework here. I'm not going to do the tough stuff today. We're going to save that tomorrow so we can spend most of the time on it tomorrow. My goal today is to do like a problem with what we're going into. It's called, we have only a couple terms that I want to go through, so we're going to be on this graph here. fact, I'm gonna zoom in on this graph just so we can kind of see that if you're on the video here. So let me zoom in on this graph. All right, so if you have graph paper, like just not your homework, but just like the note graph paper that I gave you a long time ago, you might want to draw this. We're gonna do a couple things with this. Okay, so I'm gonna start over here at -10, +2. I'm gonna go down, I'm gonna go diagonally to -4, -1, go straight across to 0, -1, go up to 3, 1, and then it's gonna go across here. There you go. Let's draw it. And again, this is, I'm going to put the coordinates down. This is -10, 2. This is -4, -1. 0, -1. This is 3, 1. And just try to draw the arrows the best you can. And again, if you don't have graph paper, just draw a rough sketch in your notes. This is going to intro what we have here. Okay? This idea here is kind of what we're going to be going into. Today I want to talk about Minimax kind of a thing. I want to, not even relative or absolute, just what a maximum is, what a minimum is, and then talk about increasing constants and decreasing functions. That's all I want to talk about today. So it's kind of lightly introducing what we're going into in this next section. There's a lot more to it, but then we'll get to the kind of the hard stuff, which is it's a leap once you see what we're about to do with this stuff. All right, so now that we have our graph, let's talk about Minimax first. There's a couple different terms. We have minimums, maximums, right? Minimum is like the low point on a graph. Maximum is the highest point on the graph. It kind of goes in common sense with what the words mean. But there's two different types of each. And that's kind of what we're going to be going into eventually. It's like there's an absolute, and there's a thing called a relative. Absolute, there's no other point that's higher, ever, in a problem, or lower in a problem, because you can have a maximum that's an absolute. Relatives, you can have a lot of relatives. Not like, family members, but I'm talking about relative minimums and maximums. There could be a lot of them in a problem, where it's kind of like peaks and valleys, where maybe the picture oscillates up and down a lot. Where, it's maybe the graph is something like this, where it just kind of keeps going up and down for a while. There's a lot of peaks and valleys, those are relatives. One of them could be a maximum, maybe not. Like in this case, we have arrows on that graph. It kind of goes up and down forever, so we don't have an absolute because you don't consider like infinity and like an absolute highest or lowest point on the graph. But in this picture, there's just a lot of peaks and valleys, so these are called relative maximums. There could be more than one. There could be different numbers, but there's just a lot of them. There's potential that they could have been the highest point or lowest point. But an absolute is that there's none. On your picture, the one that I provided you here, this picture actually has an absolute maximum. This picture. Where is my absolute highest point on this graph? -10, 2. That's an absolute maximum. Nothing went higher than that. Because if you look at everything else on the graph, everything else is below this point. It's below -10, 2. So this point is called an absolute maximum. There is no other point on this graph that goes higher. An absolute max. There is relative maxes where it kind of like did a little peak, like kind of like this was kind of like a peak where it wasn't the highest point on the graph, but it was kind of where a spot where it kind of leveled off. It's kind of like a hilltop. That's considered a relative as I approach it from the right and left. So I go from the right and left side. It did approach, kind of a peak at some point. But it wasn't the highest point in the graph, so that's called a relative. For absolutes and for absolute maximums, there can't be any higher or lower point. For relatives, you have to be able to approach from the right and the left side. So it has to be kind of a hilltop for a relative to be true. That's something a lot of people don't understand. Relatives have to have a hilltop. You have to be able to approach from the right and left side. It can't be an ending point. Okay, questions with what a max and min is. I think most people know it by common sense. It's just kind of you look at a picture. Okay, and that's something we're going to look at in Calc 1, like a lot. Like a max and min is kind of is actually a really important point, an important spot. It's called an inflection point. It's when we turn directions. So it's kind of nice that when you can recognize max and mins, like these points here are relative minimums. They're not the lowest point because this thing went down forever, but they're relatives. They eventually, it was kind of like a valley and it went back up. So they're kind of important spots. Max and mins, if you can identify where they're at, that's the separator between what we call increasing, decreasing, and constant functions. And that's the only thing I want to talk about today. That's like the thing I want to introduce. Do you agree that this graph kind of goes up and down and levels off at certain spots, right? What they're going to ask you to do is identify where those locations are, the domain over which this thing increases, decreases, and stays constant. So this is what I would like you to write down today. So let's talk about where this function is increasing. As increasing. So and again, we're looking for the domain of this thing where it's increasing. Domain. So we're going to be using those brackets and parentheses and unions because do you agree that this graph is not always increasing the whole time? It's not going up to the right the whole time. It's got its peaks and valleys going up and down. So there's breaks in the graph. Okay? So how this works, as you go left to right, as I go left to right, so I'm starting like over here, think of this like right. As I start over here and I work my way this way, where is this graph going up? So, and again, I ignore the arrows right now. I know that seems really weird. I want you to ignore the arrows. Is this graph, as I start over here going up, is it going up? Yes. So from this side over here going up to this spot right here, this thing was going up. That's an increasing motion. So that's so the domain was from negative infinity, because it looks like this thing was going down and had an arrow. It was kind of going this direction for a while. So from negative infinity up to 10 comma 2, that thing was increasing, but we only use the x numbers for domain. So up to negative 10, and notice I'm not including it. This really gets people, because most people looking at warp, it's a solid dot, you can include it, but I can't. When you do increasing and decreasing, you look at the domain of where this thing is, that negative 10 comma 2 is actually shared. It's shared between the increasing side, and if you go just to the right of negative 10 2, do you agree that it's going down in the next frame? Since it's being shared, you can't include it, because it's doing two different things, so we have to use a parenthesis here. So it was increasing from negative infinity up to negative 10, then it started decreasing for a while, then it stayed constant for a while, and then it started increasing again. So now we have a union, and now we're going to start increasing. So where did I start increasing? What was that at? 0? It starts increasing up to what number? 3. And again, we don't include it, because on the other side of 3, it stayed constant for a while. It wasn't increasing anymore. There's your domain where this function increases and decreases. Now you're thinking, okay, well, why are we looking at this? Like, that seems a little weird. This is super important when we start looking at slope of objects where things are increasing or decreasing. It's like profits. These are something that a company, that if you're going to be in like a management, or you're going to be in some type of like executive officer for like some sales management, this is something you need to look at. When did you start increasing sales? Like, what happened between those months? Because maybe you're plotting, your sales of certain objects in a month. That's what huge companies do. They look at their trend over time and they see, okay, why did we start increasing sales here? Okay, just think about like Coke products, right? Coca-Cola. They increase for a while, they decrease for a while, they increase, it depends. I think the thing that really saved that company for a while, even though they do fine, was those bottles where they print names on them, right? They make huge sales because of that. You don't know how many people would just go buy them because, duh, I bought one, just because your name is printed on it. It's the funniest thing in the world when you see it, right? Well, that's something they look at, and they look back at, okay, what did they do? What kind of advertising did they do? And they look at the trends. Well, it's important to know when did it start, when did it end? What happened in between there? What were they doing correctly? Were they just on their social media game? Because I think Burger King did that for a while, where they would just advertise on Twitter and they would just like tear companies apart on Twitter, and they thought it was the funniest thing in the world. They would just like mock other companies all the time on Twitter, and they would go after their companies and they would just make jokes about them all the time. And whoever their social media person was, they were brilliant. They were really funny, and they were really going after it. And they made sales for a while, but then it kind of tapered off. They lost the charm. They got rid of some of their management. And so like those are like little things you need to look at. Okay, so that's increasing. Now this graph did stay constant for a while. And same thing, we're going to look at where this thing like levels off, and we're looking at the domain again. So where did this thing level off, like where it goes flat across? When did it start? On that graph. Where did it level? -4 up to 0. And notice I'm not using any of those. I'm putting parentheses there because it's being shared on the right and left side. Again, I'm only using X numbers. So -4 up to 0, that it leveled off. And then where did it also start again? It started leveling off at what?
1.
About 3. 3 on the x-axis. And then it went to positive infinity, because it stayed level the rest of the time, it just like leveled off. So that's kind of the idea of what you want to look at. You want to look at, in a company, you want to look at profits versus losses. When do you stay flat, constant sales? Sometimes it's nice that you're staying above 0. You're not dipping into debt. I mean, this is probably a pretty big trend for most companies when they start. They're kind of in the negative. You borrowed a lot of money. Eventually you start to make profits. You have to buy more product for a while, so you spend a lot of capital over a couple of weeks. Where you level off because now you're starting to make sales. And then when you start to make sales, hopefully you can get above 0, and you can stay there. You can stay constant. Maybe you'll start growing from there again. Okay, that's something you want to look for. Look for supply and demand kind of thing. But that's constant domain. Okay, then this thing decreased over one particular area. Where did this thing go down? Domain of decreasing. Anyone know where was that one band where it went down from left to right? Yeah, -10 to -4, and we're not sharing it. So we're going to have the parentheses. If there was like an ending spot where it just stopped, where there's no arrows and it stopped, you could put a bracket. But we don't have that. We're sharing these numbers between all the different sets. Like -10 was definitely shared over here with the increasing, so you can't include it. It can't be in either one. It's just shared. It's in between. It's that turning point. Okay, do we feel comfortable increasing, decreasing, and constants? Okay, done for the day. I just want to do a light introduction. First time is yours today, where you can work on your homework. I didn't give you a lot of time, I gave you about 10 minutes, 11 minutes, something like that. But tomorrow we do have homework due. At your page 143, 159. Due tomorrow, keep that in mind, work on it. There you go. Stop the camera here.